So what you're going to do today is apply what we're learning here to some mobile phone technology. You're just going to determine whether or not a particular person is going to be inside a tower, a range, on the outside, so therefore gets no signal, or on the circle, so therefore getting weak signal, or there's going to be some overlap situation. So remember, we have three options. Is that if you have a circle, let's just pretend this is it, you don't need to sketch this right now, is you have three options. You are either outside the circle, you're either on the circle, or you're either in the interior or the inside of the circle. Now, of course, if we're dealing with cell phone technology, the closer you are to a particular tower is probably a better signal. Or if you're getting two tower signals at the same time, then you probably have a little bit better signal. But out here, so this person has good, this person has a weak signal because they're barely on the edge, so like a 1 bar type situation, and this person clearly is outside the range, will not get any signal. So just like we did earlier, we're just going to analyze real quick where each one of these are. So there are two parts to what you're going to do for each section, for this part and for the mobile phone part. Number one, we're going to graph the circle, and we're going to graph it well. And then we're going to estimate where these points are, but then we're going to check algebraically, like we did earlier. So the first thing here tells us two things, our center and our radius. Good, so my center is the opposite of what I see. Good, so positive 2, positive 2. So the opposite here and the opposite here. And so when we do take the square root here, that's my radius. 2, lots of 2's everywhere. So we can take a moment to graph that down here. Now notice I have a huge graph, so I'm going to change my scale. Most of us probably just count by ones, but just for a little bit of accuracy, I'm not going to count by ones. And notice where my graph's going to be. I'm going to be in 2, 2, which is in quadrant number 1. So I'm going to actually skip and count by 2's just to give myself a little bit more space. And go to 4 and to 5 here. Like so. Okay, so there's 2 and there's 4 up there. Okay, now it says that I'm at center 2, 2, which is right here. Now, how do I graph this one accurately? Well, let's go 2 in all directions. Well, it's easiest to go 2 in the north, south, and east directions. So when I go 2 here, I go up 1, up 2. So then I am right here. Going down 2 from the center. Here's my center. Going down 2, 1 and 2 here. And repeat that process for going east and west. 1, 2, so I'm going to put my point there. And from the center, 1, 2, I'm going to put my point there. So in the end, I get what looks like a diamond slash square on its vertex. Now it's tempting for us just to try to connect the dots straight, but we have to, because we're trying to be accurate here, we're trying to make a decent circle, like so. All right, now each of these points aren't labeled, so let's go ahead and label them. Maybe it'll be easier to actually have letters associated with them, A, B, C, and D. In any order. And now we can go ahead and start to graph those. So where does A live? A is 1, 2, and 1, 2 is right here. So quickly I see what my answer is. This one is inside. Now the next one, B is at 4, 2. So here's 4 down here, and 2 is right there. Oh, so it looks like B is right there, and I should label it B here. Label that A. So this one looks like it's on the circle relative to my circle that I drew. Of course, my drawing could be wrong. I could be slightly off. Next, 1, 4 is right here. Oh my, that's close. It looks like it's out. And again, probably too tough to tell, especially if my diagram is not the bestest. So here I'm going to say outside, but kind of a question mark because I might have drawn poorly. And lastly, 4, 4. Where does 4, 4 live? 4 is right here, and that's the same situation, but this one looks a little bit more obvious that it is outside. So what we're now going to do is then check algebraically like it says here. Check algebraically. So the clear ones, we can tell clearly number A here is inside, and clearly D is outside. The other two are close enough that I could have made a mistake. So that's why we're going to check algebraically. So how do we check? We take our super formula here. We're going to plug in the point and see how this relates to 4. How it relates to 4. So let's check. I'm going to do number 20 right here. And I plug in everything into here, and I put a question mark right there. So I have to take the point 1, 2 and plug it in. Now when I simplify, I have -1 all squared plus 0 squared equals with a question mark 4. This one here is 1 is clearly less than 4. In other words, since, and remember we're talking about distances, this here is talking about a distance, and this here is talking about a distance also squared, so this is my radius squared. So the distance between my point and the center, the distance between my point and the center is less than the radius, and it's all squared, which makes perfect sense, that the distance from my point to the center is less than the radius, which goes all the way across, or the radius squared in this case. So clearly, because the distance is less than, this is going to be inside.